In this video, we're going to take a look at various rounding functions available in Excel. In doing this, we're going to take a look really at this GPA column here. Let's look at this first one. Alice has a GPA of 3.92. You'll notice up here in the formula bar, the value is actually 3.919, but we only have 2 decimal points showing in the cell itself, so it rounds to 3.92. If we want to change the number of decimals that show in that cell, then we can select the cell, or in this case the entire column of cells, and right here on the Home tab on the ribbon, we can choose to increase the decimal point. This other button over to the right will decrease the decimal point and show fewer places. For example, if I were to decrease the number of decimal points to 0, you'll see that these numbers round up or down to the largest whole number. These decimal place buttons use the standard rounding convention, meaning that the important thing to note is that regardless of how many decimal points are showing in the cell, the number still remains in the cell, whatever it actually is. It may be different from what's displayed, but when used in calculations, it will use the number that's actually embedded in that cell rather than just what is displayed. So changing the number display or number format is different from doing actual rounding with a formula. I'm going to show you over here how we can do a rounded GPA. And we'll start by using the round function, equals round. You'll see there are a couple of them here, and we'll go through each of those. The first argument is the number. In this case, we'll choose Alice's GPA. The next argument is the number of digits. And this is the number of digits after the decimal place that I want it to round to. So if I choose 2 in this case, it'll round this cell or this value to the nearest hundredth. If I choose 1, it would round to the nearest tenth. If I choose 3, it'll round to the nearest 1,000th. So I'm going to hit enter on 2 here, and now the result shows 3.920. So you'll notice the value here, 3.919, even if we change the number of decimal points displayed, remains the same, whereas the value in this cell changes because of that formula. So we'll give this a title, we'll call this round, and then this will be if we round down and if we round up. Here we'll type equals round down. Now this will always round it down to the nearest whatever number place that you choose in the second argument. So here we'll select Alice's GPA again, and this time we'll choose the same number of digits, 2 digits. When we close that parenthesis and hit enter, you'll see that instead of rounding up, which in this case would make sense since that third digit is a 9, it's actually going to round down to the nearest hundredth. If we use the round up formula, we choose that number and we choose 2 digits, it's going to match because the original value already rounded up to 3.92. But let's say we change this to 3.911. Now in traditional rounding method, it would round to 3.91, which you'll see it does. But our round up formula still brings it up to the next nearest 100th. Now there are a couple of other formulas that I want to show you. The first one is the ceiling formula, and it's actually ceiling.math. And this formula rounds a number up to the nearest integer or to the nearest multiple of significance. So in this example, we'll use Alice's age instead of her GPA. We'll select that age first, and then the next argument it asks for is significance. The significance is the number of integers that we want to round this age up to. So let's suppose I do 5, and I hit enter and it's 50. The reason it's going up to 50 is because I've told it to bump this value of 49 up to the nearest multiple of 5. So that's the way to interpret this 5. It's the nearest multiple. If I were to change 49 to 42, then we can see that the nearest multiple is going to be 45. Now let's say instead of multiple of 5, I change it to a multiple of 2. In this case, it's going to remain 50 because that's still the nearest multiple of 2. But if I change this age again to, say, 41, it will now choose 42 as the nearest multiple. Now we'll label this ceiling. And then the next one, which is the same except instead of rounding up it goes down, is the floor formula. And again, it's floor.math. And so in this case, we'll choose the age again. And this time we'll choose again 5 as the significance. If we close those parentheses, you'll see this time it's now bumping it down to the nearest multiple of 5. To take a more extreme example, let's change this from 5 to 25. And you'll notice it bumps it down to 25. That's because the result that this formula gives has to be a multiple of 25. So it could be 0, 25, 50, 75, 100, or so forth. It goes down to the nearest multiple. What if we were to choose a really large number, like 777? Well, now it bumps it down to 0 because 49 is closer to 0 than it is to 777. If we do the same thing on the ceiling formula and bump that up to 777, you'll see it jumps us up to that 777 example. Now, when would we ever use something like this? Let's suppose that we're running a company and we're responsible for buying goods. We're going to keep this simple and say we're responsible for buying eggs. Our forecast, according to what our customers are telling us, is calling for 722 eggs. Let's say that we know we can only buy eggs by the dozen. So how many eggs will we need to buy so that whatever we buy will be a multiple of 12? Well, in this case, we're probably going to want to use the ceiling function so that we make sure that we have enough eggs to meet this customer demand. To do this, we would type in equals ceiling math, and then the number, which in this case is 722. Our significance will be 12. And when we hit close parentheses, you'll see it bumps it up to 732 because 732 is a multiple of 12. How many dozen is that? Well, we can take that number equals that divided by 12, and it's 61 dozen. So that gives us how many dozen eggs we would need to buy. And this is just a very simple example of how these formulas could be used. But the ceiling and floor functions can be a great way for us to determine how many actual units we would buy or sell based on how many items come in a package. This video gives you a good sense for how the round, round up, round down, ceiling, and floor functions work. And remember, on all of these functions, they actually change the result of the original data. That's what makes these different from just changing the number formats in a particular cell.